how do you measure the true cost of a drop of oil? I mean, really measure it. When we pull up to the pump or turn up the thermostat, it's so easy to just stare at that price tag in front of us and leave it at that. But if we want to truly quantify the massive, complex footprint of pulling fossil fuels out of the earth, well, it goes way beyond simple dollars and cents. It turns out there's actually a highly detailed, extremely precise way to do exactly that. Welcome to The Explainer. Today, we're diving into the nitty-gritty of the SASB accounting standards specifically for the upstream oil and gas exploration and production industry. We're going straight to the source to decode exactly how the world's top financial institutions calculate the real-world impacts of oil extraction. Okay, let's dive right into this. Here is our visual roadmap for today. 1. The scope of upstream E&P. 2. Measuring the environmental footprint. 3. Protecting ecosystems and habitats. 4. Communities, rights, and safety. And 5. The financial climate risk. Section 1. The scope of upstream E&P. The physical reality of extraction. So the framework we're looking at today comes straight from the SASB standards, which are now stewarded by the International Sustainability Standards Board, or ISSB, alongside the IFRS Foundation. And look, this isn't just some arbitrary wish list of good ideas, right? These metrics provide a totally impartial, globally standardized language. It's literally the language investors use to assess sustainability-related risks that could genuinely hit a company's cash flow or cost of capital. To really understand this, we need a visual overview of how the standard actually classifies the industry. It separates things to illustrate the major differences in how we get our energy. On one side of the coin, you've got the development of conventional reserves. This is your traditional, classic oil and gas drilling. But on the other side, we have unconventional reserves. This is where things get really complex. We're talking about extracting shale oil and gas, processing heavy oil sands, and even tapping into gas hydrates. These extraction methods are fundamentally different, and as the push for these unconventional resources explodes, it brings along entirely different carbon intensities, massive water requirements, and a whole new set of regulatory risks compared to traditional drilling. And here's the thing, whether we're talking about developing those conventional or unconventional reserves, this E&P, which by the way stands for exploring, extracting, and producing crude oil and natural gas, happens in very distinct environments. We've got onshore terrestrial sites and offshore marine sites. The physical reality of the environment, whether you're running a terrestrial fracking site in a dry region or operating a massive deep water offshore rig, that physical location dictates the exact risks and the very specific metrics we absolutely have to measure. Section 2. Measuring the environmental footprint. Air and water impacts. Let's bust some industry jargon right out of the gate. You hear the phrase Scope 1 emissions thrown around a lot, right? Well, under this standard, Scope 1 simply refers to the direct greenhouse gas emissions released straight into the atmosphere from sources the company literally owns or controls. We are talking about flared hydrocarbons from burning off unrecoverable gas. We're tracking process emissions from chemical transformations, intentionally vented emissions from storage tanks, and even fugitive emissions. Those are those sneaky, accidental leaks from valves and pipe flanges that engineers actually have to track down and fix. It is an incredibly detailed accounting of pretty much every gas molecule leaving the site. Now, what's really interesting about this is how they track the liquid footprint. Take produced water and flowback. This refers to the actual brine pulled up from the earth during extraction, plus all that hydraulic fracturing fluid that comes rushing back to the surface. The standard mandates that companies measure the exact volume of this water. They have to disclose the exact percentage that's discharged, injected back underground, or recycled for other wells. And this metric is absolutely crucial, especially when these companies are operating in regions already suffering from high or extremely high baseline water stress. It's a huge deal. Okay, so we know how to measure the direct air and water outputs, but here's the million-dollar question. What happens when these massive physical reserves overlap with the most vulnerable ecosystems on our planet? Section 3. Protecting ecosystems and habitats. The cost of proximity. Take a look at the top rows of this table, detailing biodiversity impacts. The standard meticulously tracks hydrocarbon spills. But, and this is key, it doesn't just ask for a total volume. No, it specifically demands that companies disclose the volume of spills occurring in the Arctic, as well as spills that hit shorelines with an environmental sensitivity index ranking of 8 to 10. We're talking about super fragile environments like mangroves and swamps. A spill there, it's not just an ecological tragedy, it means vastly more complex, incredibly expensive cleanup operations, which creates massive operational risk. To really gauge this risk looking forward, we have to decode another piece of essential terminology: proved versus probable reserves. Basically, proved reserves have a super high certainty of being economically extractable right now. Probable reserves? Slightly less certain. Well, SASB requires companies to explicitly disclose the percentage of both their proved and probable reserves that are located in or even near sites with protected conservation status or endangered species habitats. It literally forces companies to put a hard number on their ecological proximity risk. So, we've looked at the environmental and ecological risks. But what happens when these sprawling oil and gas operations overlap not just with nature, but with human populations?
Section 4. Communities, Rights, and Safety. The human element.
25. Honestly, this is a pretty sobering metric right here. The standard requires companies to disclose the percentage of their reserves located in or near areas of active conflict. And how exactly is an active conflict objectively defined? It's defined as a conflict resulting in at least 25 battle-related deaths per calendar year. Operating in these zones presents immense security and human rights risks that investors absolutely must be aware of. And this brilliantly illustrates how the human element extends to vulnerable communities too. Companies must formally disclose the percentage of their reserves near indigenous lands. More than that, they have to show evidence of free, prior, and informed consent before disrupting those territories. It's a huge accountability measure. Of course, it's not just local communities, it's the workers themselves. Look at this number, 200,000. This is the baseline formula used to objectively calculate the total recordable incident rate, or TIR. Why 200,000? Because it represents the exact number of hours that 100 full-time workers, working 40 hours a week for 50 weeks a year, would log. By using this standard denominator, we can objectively compare how effective different companies are at keeping both their direct employees and their contract workers safe in what are notoriously harsh and hazardous environments. All right, so we've tracked the physical reality, the emissions, the ecosystems, and the human element. Now, we really need to pull back and ask the ultimate macro-level question. How does a global transition to a low-carbon future actually affect the monetary value of all this remaining oil? Section 5. The financial climate risk. Reserves valuation and capital expenditures. Take a close look at this second row of this reserves valuation table. It demands something pretty incredible. Companies must actually calculate and publicly disclose the estimated carbon dioxide emissions embedded in their proved hydrocarbon reserves. Basically, they have to take the physical weight of their unextracted oil and gas sitting down there in the ground, use specific formulas, and calculate exactly how much potential CO2 is just waiting to be unlocked. But the true financial stress test comes next. The standard requires these companies to analyze the sensitivity of their reserves against 3 distinct future price projections published by the International Energy Agency. They literally have to stress test their portfolios against a current policies baseline, a new policies scenario, and a highly aggressive 1.5 degrees Celsius sustainable development scenario. Companies have to show how regulatory limits on emissions and the inevitable rise of alternative energies might literally reduce global demand, alter extraction costs, and totally change the core value of their assets. So the crucial point is captured perfectly right here in this quote from the standard itself. Companies must report the, quote, sensitivity of hydrocarbon reserve levels to future price projection scenarios that account for a price on carbon emissions. If governments put a strict financial price on emitting carbon, the cost of extraction goes up. And if the cost of extraction goes up, well, certain probable or even proved reserves may suddenly become way too expensive to pull out of the ground. Carbon pricing literally changes the hard financial definition of what is profitable to extract. We started out today by asking how to measure the true cost of a drop of oil. And as you've seen, the accounting goes far, far beyond the barrel. It includes the methane leaked into the air, the flowback water injected into the earth, the proximity to endangered shorelines, the rights of indigenous communities, and the physical safety of the workers on the rig. So if the transition to a low-carbon economy literally revalues the Earth's remaining oil, taking all of these complex metrics into account, are we prepared for the new cost? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll see you next time.